In our last session, we mastered supervised learning, or we looked at supervised learning, where AI learns from well-labeled data, right? Like the analogy of the chef with a very well-labeled cookbook. But what if you don't have all the answers? What if you have a massive amount of data, but you don't know how to label it, or labeling it is practically impossible, or maybe even just labeling it, it's too expensive for you, and you don't even know what patterns you're looking for yet? This is where AI transforms into a curious explorer, venturing into unknown or uncovered hidden structures and insights, right? Today, we're diving basically into that world of unsupervised learning and its very powerful cousin, semi-supervised learning, and basically revealing how AI can discover patterns and make sense of chaos all on its own. So imagine you give a child a huge box of toys they've never seen before, and you ask them to sort the toys, but you don't tell them what any of those toys are. You basically just say, group the ones that look similar. This is the essence of unsupervised learning, right? In unsupervised learning, the AI algorithm is given a data set with no labels, no predefined answers, and no teacher to correct it. Its goal is just to find inherent structures, patterns, or relationships within the data by itself. It's like a child just observing the toys and thinking, these all have wheels, so they probably are cars, or they all have soft body and hair, so they are dolls. The AI isn't predicting any specific outcome. It's just discovering underlying organizations in the data and labeling them or sorting them. This is incredibly powerful when you have a lot of data, but you don't know what you're looking for, or when labeling data is simply too costly or time consuming. Now, there's different methods of doing this, right? We have clustering, we have anomaly detection, and then we have dimensionality. Reduction is just the explorer's toolkit, right? So, our self-taught organizer, the AI, uses a few key techniques in its exploration, which are these techniques we explain. So let's start with the first one, which is clustering, or grouping similar items. So this is the most common form of unsupervised learning, right? Like we said earlier on, we used the example of a child grouping all the cars together, or all the toys together, or even all the blocks together based on what it noticed in these patterns. So the AI itself identifies data points that are similar to each other based on their features and groups them in clusters. It doesn't know what the groups are, just that these items belong together, right? For example, in customer data, you can cluster, or clustering can identify distinct customer segments without being told what those segments are beforehand. All right. Now, the second one is anomaly detection, or spotting the odd one out. Sometimes the goal isn't to group. It's to find what doesn't fit in that group, right? So imagine the child finding a tiny little sparkly unicorn amongst a pile of those ordinary items of animals or toys. It stands out. It's not really a toy. It's just something very different, right? This is what is called an anomaly. An anomaly detection is basically about finding data points that are significantly different from the majority. So anomaly detection is very useful in detecting fraud, right? I also worked with a team that has used anomaly detection before, particularly in identifying transactions that don't typically fit the patterns within a transaction or a financial transaction, right? And then it's also used a lot in cybersecurity threats or defective products in an assembly line. You're looking for that one product that is an anomaly or that is very different from the rest of the products, and to pull it out, right? That's another type. Then we also have the dimensionality reduction, or basically just simplifying the concept, right? So what this is data can often be incredibly complex with hundreds and thousands of different features. Now, imagine describing a toy by its color, by its size, by its material, by its weight, by its country of origin, brand, cost, and so on. That's a lot of dimensions, right? So dimensionality reduction is like finding simpler ways to describe that toy, maybe just by its play value or its durability. So the AI identifies the most important features in a data set and reduces the number of variables, making that data easier to visualize and process, while still keeping most of the important information needed for the data. And it's usually very, very important for handling large, complex data sets efficiently. where does unsupervised learning shine, or what are some of the business applications of unsupervised learning, you may ask? So, unsupervised learning might seem very abstract, but it's really practical. Let's look at some examples. I already gave one of fraud detection, right? It automatically, and it's very useful, it automatically flags unusual credit card transactions or network login attempts that that deviate significantly from the established norms. Also in recommendation systems, right? Identifying groups of products or movies that are often purchased or watched together, which can be used to recommend new items. Then when you also look at customer segmentation or customer grouping, you notice that grouping customers based on their purchasing behavior or demographics to create targeted marketing campaigns. This is where it also comes in very useful, even if you didn't define those segments beforehand. Unsupervised learning is very helpful in this. Then of course, data compression and visualization, just simplifying complex genomic data or high dimensional scientific data to make it understandable and usable. This is where you have supervised learning's power coming in strong. Now, let's look at semi-supervised learning, right? So sometimes a little guidance goes a long way to help. What if, just what if, you have a huge amount of data, but you also have a small amount of labeled data? A few examples where you know the answer. This is the sweet spot, right, for semi-supervised learning. So let's use the analogy of the child before, the child sorting those toys. But this time you give them just 10 clearly labeled toys. One is a car, one is a doll, one is a block, and so on. Now, this is a car, you say, pointing to a single example, right? The child has a starting point because they know that, okay, this, if I see this item, it's similar to a car. So they have a starting point and they understand the concept of car, a doll, and a block. They can use that small initial knowledge to be more effective and quickly sort massive piles of unlabeled toys. So the labeled data provides an initial direction, right? Helping the AI to learn better, or to learn better features and patterns from this huge pool of unlabeled data. So it combines the best of both worlds, the precision of supervised learning with the scalability of unsupervised learning. And this approach is invaluable when obtaining large amounts of labeled data, which is also very expensive and super time consuming, but initial labeling is very feasible. So how does this hybrid approach work, right? Let's consider this a teacher-assisted discovery, as it's most often referred to. Typically, a semi-supervised learning model will, one, learn from the few labeled examples. It first builds an initial understanding based on the small data set where the answers are known, much like a supervised learning model. Then secondly, or you would apply this to the unlabeled data. So first, it will learn from the examples given to it, then it would apply this to the unlabeled data, right? And uses this initial understanding to make predictions or guess labels for the vast amount of unlabeled data given to it. Then the last part, the third part, it refines and it repeats. So the model identifies predictions it's most confident about and adds those pseudo-labeled examples to its training set, right? It then retrains itself with this expanded data set. This helps it to improve its accuracy and ability to learn from the unlabeled data more effectively. So this iterative process allows the model to leverage the rich information in the unlabeled data, which is guided by the initial small set of ground truth labels that were given to it. And it essentially teaches itself by making educated guesses and continually refining its understanding, right? Now, what are some of the use cases here? Semi-supervised learning is particularly powerful in domains where getting labeled data is some sort of a bottleneck, right? Image and speech recognition. Those are things that are a little at the edge labels, right? Training models to recognize new objects or new voices when only a small portion of that data has been manually tagged, it becomes a little difficult. Now, web content classification. So automatically categorizing vast amounts of web pages, documents, when only a few of them have been manually reviewed. Then medical diagnosis. This is another very great area, right, where you're leveraging small set of expert labeled medical images or even patient records to classify as much larger unlabeled data sets as possible, maybe assisting radiologists or pathologists. And when it comes to medical or the health sector, it becomes really tricky because of the compliance and the regulations that surround this. Then of course, anomaly detection with feedback. That's another one. Initial unsupervised anomaly detection is usually followed by human experts labeling a small subset of the detected anomalies, right? And this basically allows the system to learn more accurately for future detections. So let's just put this into practical context, right, and use a customer persona identification. Imagine you have a massive database of customer information, their browsing habits, their purchase history, their demographics, but you don't have predefined customer segments. You want to understand who your different customer groups are. So you collect unlabeled data, you gather all your raw customer interaction data, and this is your pile of the unlabeled toys that we spoke of. Now let's apply clustering, right? Unsupervised learning. And unsupervised learning algorithm, like the K-means clustering, basically analyzes this data and automatically groups customers who exhibit similar behaviors or characteristics. Occasional discount hunters like some of us, or browsers who rarely buy, right? And then the algorithm doesn't know what these groups are, only that they are very distinct. Then it will define the personas. Now, with these clusters identified by the AI, a human analyst comes in and they examine the characteristics for each of these clusters and give them meaningful names. Perhaps it's the early adopters, the value seeker, or the brand loyalist who shop very often, right? These are your different customer personas. Now, let's leverage it for marketing using semi-supervised touch. If you have a small subset of customers for whom you know their persona from the surveys that you might have done in the past, you can use semi-supervised techniques to quickly assign personas to many more new unlabeled customers, right? And this just allows for highly targeted marketing, product development, and customer service strategies. And it's just how AI can help you understand your audience and on a deeper level, even without explicit upfront definition. Unsupervised and semi-supervised learning are essential tools in the AI toolkit, and it just empowers machines to find hidden insights and learn efficiently when explicit guidance is limited, right? Whether it's discovering new customer segments, detecting anomalies, or just making sense of complex data, these approaches basically unlock tremendous value. And this ability to learn from an unknown is a cornerstone of advanced AI. Now that we've uncovered what foundational types of AI, let's explore another dynamic paradigm, another type of machine learning: reinforcement learning in practice. And this is where AI learns through trial and error, just like we do. You don't want to miss this one, because it's going to be AI in action, practical, as it makes decisions and learns from the consequences. And I want to make sure that I'll give you the best explanation for everyday life and run it live so you really understand. Just so you don't miss it, if you haven't yet subscribe to the channel, like this video if you learned or you got value from it, and make sure that you share it with a friend who can learn from this. And again, if you're interested in the whole AI literacy course or segment, don't forget to enter your email on the waitlist, and once it's released, I will be sure to send you the resources. Thank you once more, and I'll see you next time. Bye.